myself Revati and I am a final year student. I am pursuing my bachelor's degree in National Engineering College Kovalpatti and I am doing my internship in Emertxe. So today I am going to present my microwave oven simulation. The first is the table of contents. Today we are going to see topics learned during internship. What is microwave oven, requirements, embedded systems, a microcontroller and microprocessor, PISM lamp, CLCD, matrix keypad, ISR, timer and project implementation. Topics learned during the internships are Introduction to C language, arrays and pointers, functional strings, storage classes, conditional loops and operations, Introduction to embedded systems and microcontrollers, MP Lab XID, XC8 compiler, PIXM Lab, Introduction to various peripherals of 16F877A, and I also attended quiz and attended the DIJA workshop. Then we are going to see the what is microwave oven. Microwave oven is relatively small box-like oven that arises temperature of food by subjecting it to a high frequency electromagnetic field. In that we have several modes in various microwave oven. Let's also see what is microwave oven in briefly. Microwave oven, also called microwave electronic oven, appliance that cooks food by means of high frequency electromagnetic waves called microwaves. A microwave oven is relatively small. As I said in this point, the microwaves are absorbed by water, fats, sugars and certain other molecules whose consequent vibrations produce heat. The heating thus occurs inside the food without warming the surrounding air, which greatly reduces cooking time. As we see, there are several modes in various microwave oven. We are going to implement the 4 modes: micro mode, grill mode, convection mode, start mode. Micro mode. When you simply want to cook something like rice, Maggi, boiling potatoes, we are used this mode, that is the micro mode. Maximum time that you set for cooking is 60 minutes. Then grill mode. It is simply used for grilling. Next, we can set the time as per the meal. In convection mode, we can use for baking of cakes and cookies, etc. In this mode, user can set the oven to preheat for a particular temperature. We want to preheat the oven. After preheating only, we can set the time according to their foods. Next, we are see the requirements: knowledge in embedded C, MP Lab XIDE, XC8 compiler, PIXM Lab. In that we want to know about CLCD, matrix keypad, ISR and timer. Next, we are going to see about the embedded system. And the embedded system is a combination of computer hardware and software designed for a specific function. Embedded system may also function within a larger system. The systems can be programmable or have a fixed functionality. In embedded system, we have analog components, software, converters and digital components. In all the system, we have analog and digital components. Programmable or a fixed functionality. That is, the embedded system can be programmable or have a fixed functionality. Industrial machines, consumer electronics, agricultural and processing industry devices, automobiles, medical equipments, cameras, digital watches, household appliances, airplanes, vending machines and toys, as well as mobile devices are possible locations for an embedded system. While embedded systems are computing systems, they can range from having no user interface, for example, on devices designed to perform a simple task, to complex graphical user interface, such as in mobile devices. User interfaces can include buttons, LED, that is the light emitting diodes, and touchscreen sensing. Some systems use remote user interface as well. Markets and markets. A business to business research firm predicted that embedded market will be worth 116.2 billion by 2025. Chip manufacturers for embedded system include well-known technology companies such as Apple, IBM, Intel, and Texas Instruments. The expected growth is partially due to continued investment in artificial intelligence, mobile computing, and the need for chips designed for high level processing. Examples of embedded system. Embedded systems are used in a wide range of technologies across an array of industries. Some examples include automobiles, mobile phones, industrial machines, medical equipment. How does an embedded system work? Embedded system always function as a part of complete device. That what's mean by the term embedded. They are low cost, low power consuming small computers that are embedded in other mechanical or electrical systems. Generally, they comprise a processor, power supply, and memory and communication parts. Embedded systems use the communication ports to transmit data between the processor and peripheral device, often other embedded system using a communication protocol. The processor interrupts this data with the help of minimal software stored on the memory. The software is usually highly specific to the function that the embedded system serves. The processor may be a microprocessor or microcontroller. Microcontroller are simply microprocessors with peripheral interface and integrated memory included. Microprocessors use separate integrated circuits, that is IC, for memory and peripherals instead of including them on a chip. Both can be used, but microprocessors typically require more support circuitry than microcontrollers. Because there is less integrated into the microprocessor, the term system on a chip SoC is often used. SoC include multiple processors and interface on a single chip. They are often used for high volume embedded systems. Some example SoC types are the application specific integrated circuit ASIC and the field programmable gate array FPGA. These are studied in the VLSI, that is the very large scale industries. Often embedded systems are used in real time operating environments and use of real time operating environment RTOs to communicate with the hardware. Near real-time approaches are suitable at higher levels have increasingly decided the systems are generally fast enough and task tolerant of slight variation in reaction. In these instances, stripped down versions of Linux operating system are commonly deployed. Although other OS, that is the operating systems, have been pared down to run on embedded system including embedded Java and Windows IoT. There are several characteristics of embedded system. Additionally, embedded system can include the following characteristics. Typically consist of hardware, software and firmware. Can be embedded in a larger system to perform specific function as they are built for specialized tasks within the system, not various tasks. Can be either microprocessor based on microcontroller based. Both are integrated circuit, that is the IC that give the system compute power. These are about the embedded systems. Then we are going to see about the microprocessor and microcontroller. As the name implies, it is a processing device that converts data into information based on some sets of instruction. That is the microprocessor. It is a very compact electronic chip due to which it is referred to as microprocessor. In microcomputers, the microprocessor is used as the CPU, central processing unit. A typical microprocessor consists of two major parts, namely ALU, that is the arithmetic logic unit, and CU, that is the control unit. Intel 8085, 8086 processing chips are the example of microprocessor. A microcontroller is an electronic system which consists of processing element, a small memory. In that we have RAM, ROM, EPROM, next IO ports, etc. on a single chip. Therefore, a microcontroller is a tiny resemblance of a microcomputer. It's a quite small and low cost electronic device which is used in several electronic appliances as the main functioning device. Then we are going to see about the Pixim Lab. Pixim Lab is a real-time emulator of a development board with MP Lab X AVR GDP debugger integrations. PICSIM Lab supports microcontroller for PICSIM, SIMR, UCSIM, GEMU STM32, QEMU ESP32 and GPSIM. PICSIM Lab has integration with MPLAB X or Arduino IDE for programming the microcontroller's board. The features are real-time emulation, Arduino support, ESP32 support, STM32 support. CLCD connected, which means the connected limited device configuration. It is a set of standards, libraries and virtual machine features that serve as the basics for APIs targeted at device with very limited resources. A large number of feature phones as well as some embedded system fall under this category of devices. Then we are going to see about the matrix keypad. As the name indicates, it is one of the keypad. Most of the applications of embedded system require keypads to take the user inputs, especially in the case where an application requires more keys. With simple architecture and easy interfacing procedure, matrix keypad are replacing normal push buttons by offering more inputs to the user with the lesser input output pins. Next, we are going to see about the ISR, that is the interrupt service routine. It is a software routine that hardware invokes in response to an interrupt. ISR examines an interrupt and determines how to handle it, executes the handling, and it then returns a logic interrupt value. If no further handling is required, the ISR notifies the kernel with a return value. Then we are going to see the timer. Timer is a specialized type of clock which is used to measure time intervals. A timer that counts from 0 upwards for measuring time elapsed is often called a stopwatch. It is a device that counts down from specified time interval and used to generate a time delay. For example, an hairless glass is a timer. Then we are going to see about the power on displays of 4 modes: micro mode, grill mode, convention mode, start mode and time up. These are the images of the stimulation. While I took a picture during the simulation of the microwave oven, the first picture represents the power on. Next picture is a display of 4 modes. In this picture we are going to see about the micro mode, and the second picture represents the grill mode. As we are seeing that while we are doing the grilling of meals, we are putting this mode and we want to cook. Then it is the convention mode. I took images related to the convention mode, then start mode and time up. Finally, if it got times up, then the machine stops works. Then we are going to see the project implementation. Let's see the implementation of the projects. Thank you for this opportunity to present my video. Thank you.